the name of my project is BrewMatch. And to tell a little bit more about my problem statement, who is BrewMatch? So BrewMatch is a company which is essentially an online coffee shop directory platform designed to connect users with local cafes. So the primary customers for our business is coffee experts. So this can be like baristas or cafe managers or anyone who is working in the coffee industry. Also, casual coffee drinkers, students, professionals, and just about anyone with an adventurous mind who's looking for a unique and fun experience when choosing a cafe. So this is how our platform BrewMatch is set apart from traditional map services like Google Maps or Yelp, because ours is very much curated towards coffee shops. And the reason why BrewMatch kind of the idea came to me is because of this increasing trend of experience-based consumption, where 80% of consumers are more likely to engage with brands offering personalized experiences. And what are some of the services that BrewMatch offers? So the main one that we were going to be focusing on is this quiz-based matching algorithm, right? So what essentially our users does is they go onto our website, they can take a quiz about their lifestyle choice, their ambiance preference, aesthetic preferences, food options, and then our algorithm will then match them with a cafe from our directory. And we also have additional services like barista profiles, where our users can explore background, experience, and specialties of baristas. Users can also rate and review their coffee shops, and there will be also search and filter options for coffee shops. And how does BrewMatch make money? So essentially, it's through advertising and featured listings. So cafes can pay a specific amount of money for their placement to be a priority in search results, right? We can also offer subscription services for cafes to access extra features like barista profiles. So we can like incentivize different features and earn some money that way. We can also have affiliate partnerships with other coffee shops, other coffee suppliers, and just any other vendors. So this is the attribute catalog that I have, and so this is there are certain information about certain entities. So the first couple rows that you can see are about the user. So the user ID, username, password, email, what date did they join, their location, and then we have the cafe information. So cafe ID, name, address. One thing to note here is that the address is already broken up by state and zip code, so it is not an non-atomic value. We also have opening time, closing time, average rating, description of the coffee shops, and for baristas we have simply just name, ID, their bio, their years of experience, and specialty. And quiz ID, this is the quiz information. Each quiz will have a number associated with them to identify them, and it's gonna give us a certain amount of results, and we're gonna record the time that the quiz was taken. So this is the pre-normalization table I have. This is some made up data with the help of AI and a little bit modification as well. Yeah, as you can see, this is pretty basic. And just one thing to note here, that this is a very long table. This is not two different tables. It's just one table kind of shown by breaking it up. And for the next step here, I'm just writing a simple SQL query to create a raw table with all the attributes I have mentioned in the attribute catalog. And if I describe the raw table, you can see on the right hand side I have some like the descriptions of the attributes of raw table. And for the next step, I am loading in the raw data into the raw table. And this is on the right hand side, you can just see like an example of that. So if I select user ID, username and password, and also email from the raw table, I get all the data values that I just inserted. So moving into normalization, for first normal form, the requirements are that there would be no repeating groups, no repeating values, and a primary key. So for my long table, and again here you can't see the whole table, it's very long, but the only thing I changed about my data here is that I added in a primary key called entry ID, because I noticed that I have user ID, I have a cafe ID, however those aren't really representative of the whole entry itself. So I added in that, and I thought that would be more suitable to work as a primary key for each of the fields. For second normal form, here the requirements are that it has to be in first normal form, and there can't be any partial dependency. So in order to follow that, I decided to break up my long table into 4 different tables that represents the identities. So you can see I have a user table, a barista table, a cafe table, and a quiz table. And for third normal form, we have to eliminate any transitive dependency and have to make sure that our data was already in second normal form. So here, one thing that I noticed in the quiz table is that if our website decides to use an algorithm like KNN or K nearest neighbors, which gives you multiple results, not just one, in that case, my quiz table is not suitable, or it doesn't work really well. So I decided to break it up and make another table called results, and I decided to link those results with the quiz ID, as you can see on the slide. And this is the ERD using crow's foot notation. So in each of the boxes, we have each of the entities and their attributes. And so from user to quiz, it's a one-to-many relationship, because one user can take multiple quiz, but a quiz cannot be taken by multiple users. And then from quiz to results is also one-to-many relationship, because a quiz, as we talked about in the earlier slides, can have multiple results, but it doesn't really make sense if we say that multiple results has a result belongs to multiple quizzes. And then for cafe and barista relationship, I thought this was a bit interesting, because there can be multiple baristas working in a cafe, but a barista can also have 2-3 jobs, right? So a barista can also work in multiple cafes. So I stated that as a many-to-many relationship. Then this is where we move on to loading our raw table into a normalized schema. So the first step for that is to basically just create all the tables. So I had 1 table earlier, and now I have 5 tables. So this is just me creating those tables. And now I move on to loading the data into their respective tables. So the first box here shows you me inserting those values into user table, and then the second box here at the bottom shows you select star from user table, so all the infos, and you can see it really corresponds to what we had earlier. This is the same thing done for cafe table, and yeah, the same thing done for barista table all the other tables to transform our data into a complete normalized schema. And so for queries, I decided to go with two queries. The first one is write a query to retrieve the number of quizzes a user has taken. So as I talked about earlier, a user can take multiple quizzes, right? And so how that works is on the left join, this is where the data from the quiz table and the user table is being combined, and u.userid equal q.userid. This part is really checking for the user ID what user has taken what quiz essentially, and then the count q.quizid is counting up those numbers, and group by username. So this part is grouping each of the username, um, so so that we can see the count of each of the members. One thing I wanted to also mention here: the left join ensures that the table on the left, all of the entries are counted for. So we will also see results for users even if that user haven't taken any quiz yet. So the count would be 0, which is accurate. The second query I worked on is to retrieve the cafe names from the results of a quiz. So let's say we have result, right? We have the ID. I want to go back to the cafe table and say what is the name of that cafe? What is the name that corresponds to that cafe ID? So I'm doing that in the join section, looking for the cafe ID that is associated with the quiz, and then finding the equivalent in the cafe table, and then I'm retrieving the cafe name, and also I have a where condition, which is essentially this is where all the number of the quiz will go, like the specific quiz that we're referring to. And for final reflections, I just want to say that this was a great opportunity for me to learn how to create tables in databases, how to normalize data, how to query data to retrieve useful information. And one other thing that I really liked is that it gave me a chance to practice developing a business, selling that idea, and kind of think more practically from a real world perspective. And yeah, that's it for my presentation. Thank you so much.